Hello everyone, my name is Rithun from CKF and welcome to Java Jumpstart. Today we'll be looking on how a compiler works in Java. Whether you're a beginner, just starting out, or someone looking to solidify your understanding, this explanation should give you a clear overview of what happens when you compile a Java program. Let's dive right in. First thing first, what exactly is a compiler? A compiler is a specialized program that translates code in a high-level programming language, like Java, into machine code that a computer processor can execute. Essentially, it bridges a gap between human-readable code and binary instructions a computer understands. Example, here's a simple Java program. We'll explain these components on later videos, but for now, let me explain you this component. System.out.println prints out a statement, and we'll input what statement we want to print in here. For example, if we put in hello world, in this section, hello world will be printed out. This code is easy for us to understand, but your computer cannot run as it is. The compiler's job is to translate this code into something your computer can execute. When you write a Java program, you do so in a text file with a Java extension. So when you first write your code and click run, a .java extension will be added right here. And this is because it's a Java file. This file contains your source code written in a Java programming language, but a computer can't run this code directly. That's where the Java compiler called Java comes in play. When you run Java, it performs the following steps. The compiler reads your source code and breaks it down into tokens. Tokens are the smallest units of meaning, such as keywords, operators, and identifiers. Hello world here would be converted into a token. Next, the compiler checks if the arrangement of these tokens to ensure they follow the syntax rules of Java. For example, this line is written correctly. If we take away the semicolon, it will be written incorrectly, because a semicolon ensures that the line is ending. If there's no semicolon, our computer cannot know when the line is ending. And when we try to run this line, an error will pop up. This is called a syntax error. If there is no syntax errors, then our computer ensures that a code makes logically. Now, the compiler translates, checked, and validated code into an intermediate form known as bytecode. This bytecode is stored in a .class file. So after we run our code, a .class file will be created automatically. This is the code that our computer understands, and all our information in this file will be converted into this file. And we can understand some parts. The print stream represents the print statement. And here's our class. For our Hello World program, Java will generate a .class. This bytecode is not meant to be human readable, but is essential for the next step. So what happens with this bytecode? The .class file contains the bytecode is executed by the Java Virtual Machine, or JVM. The JVM is an interpreter that translates the platform-independent bytecode into machine-specific instructions. When you run a program using the .java command, the JVM takes over. The JVM's class loader loads the .files into memory. When you run Java Explorer 111, the class loader loads Explorer111.class into memory, ready to be executed. The JVM verifies the bytecode to ensure it doesn't violate any security constraints and is safe to execute. If there was a tampering attempt with the bytecode to perform unauthorized operations, the JVM would catch it there and throw a verification error. Now, JIT, just-in-time compilation. The JVM may also use a technique called just-in-time compilation. This process converts the bytecode into native machine code just before execution, which can speed up the process. As the system.out.println hello world statement is executed, the JIT compiler might optimize it for faster output, depending on the system needs. Finally, the JVM executes the machine code, and your program runs on a computer. You see the output hello world on your screen, which is the final result of the entire process. The Java compilation process provides several advantages. Platform independence, because the line is independent from all other files. The JIT compiler optimizes bytecode at runtime, ensuring your Java applications run efficiently. In larger applications, frequently executed methods might be compiled to native code on fly, making them run faster than they interpret directly. In conclusion, that's how a compiler works in Java, from translating your human-readable code into platform-independent bytecode to executing it on any machine with JVM. Java's compilation process is what makes it a powerful and versatile language, and also what makes it better than other programs, for example, Python. Once a single error is caught, the code stops there. But using JVM from Java, it runs the entire files, catching all the errors possible. Now that's it for today, and please check out our previous codes, previous videos, and our next videos, and I'll see you in the next one. Thank you.